Good evening, sir.
Good evening, guys.
Good evening, sir.
Good evening, sir.
How are you guys?
Good evening.
Yeah. So the last session we are discussing about arithmetic progression, some practical questions we are not done. I told you we will do those practical questions in next term. Like in revision, I will explain the rest of the questions in arithmetic progression because it is not part of the first term syllabus. So what topic we planned to discuss today, guys? Anyone can able to remember?
Sir, can we start with triangles?
No, coordinate geometry. I planned for coordinate geometry and I told very clearly why coordinate geometry. Because if I completed coordinate geometry, what is remaining in first? I will after that I will start triangle because coordinate geometry hardly will take 2 sessions. That's it. So, but triangles will take a lot of time. I will explain a little bit slowly and elaboratively. Will take might be 2 weeks or 3 weeks. I will explain. But that means 6 sessions or 9 sessions I will take to explain the triangles. And might be less time because triangles is split into both the terms. So we will sit more time and we will have to solve more numericals other than textbook numericals we have to solve. Then we will get full clarity over the triangle. That's the reason I planned to start the coordinate system. Is it fine, guys? Like for number wise, we can complete one topic. That's the reason I'm saying. Second, guys. Yeah, guys, shall we start with coordinate geometry? We can wind up within 1 or 2 sessions. Is it fine? Or shall we start only triangles? We'll complete line by line according to your syllabus. That's the reason I told we will start triangle coordinate geometry. Some of you, Arman, please.
Sir, can we start with triangles?
Yeah, let's first we have to see what is there for first term. I have to check. This is first term syllabus. Triangles, a line drawn to parallel to one side, triangle intersect with two sides distinct point. The two sides are in the same ratio. Line divides sides. Yes, almost all everything is there in triangles for first term. What about second term syllabus? Yeah, second term there is no triangles concept. Yeah. Anyone can start the session with what is the definition of a triangle? Anyone, guys, please. What is the definition of a triangle? What is the definition of the triangle? What are the basics? We already completed related to triangles in our earlier classes. In grade 9 or something.
Polygon with 3 edges and 3 vertices.
Correct. It's a polygon of 3 edges and 3
Vertices.
A closed figure of 3 sides, different ways. Correct. Now, what are things we done from grade 9? Anyone can able to recollect in grade 9 what we have done? In grade 9 or 8, what we done?
Sir, congruency.
Congruency. Next.
Angle sum property.
Sir, inequality.
Angle sum property. What is meant by angle sum property?
Sum of 3 sides of a triangle equal to 180 degree.
Yeah. So triangle is a combination of 3 angles. If I'm taking ABC is a triangle. Angle A plus angle B plus angle C is equals 180 degrees. This is called angle sum property. Next one is congruent. Anyone can explain what is the definition of congruent?
Ma'am, sorry, sir, 2 exact figures, sir.
2 exact figure or 2 exact figures. Yeah, 2 exact diagrams. Yeah, congruent. Any thing we can able to remember from the congruency?
Sir, SS is congruent.
SS is congruent.
A is a congruent
A,
condition.
C, and
R
RH
is
is congruent.
Same size and same shape. Correct?
Yes, sir.
Now, along with this, we are going to discuss about similar triangles, similar figures. So I am coming to the definition of the similar figures. We know when it comes to congruency, figures which have exactly guys, just hold on a second. Sorry guys, sorry for the interruption. Figures which have exactly the same shape, and same size is known as or said to be congruent. We are having some discussions over this congruent and some theorems we discussed from the congruent. When it comes to similarity, it is need not to be same size. If it is same shape, figures which have exactly the same kind of shape, but not necessarily the same size. Or said to be similar. Can you give any example of similar figures? Later I will conclude to the triangles. Anyone can give the similar? Guys? Anyone can give
Sir,
the
a
similar?
small circle and a large circle, sir.
Circle with different radii. The first example is circles with different radii. That is different radiuses. We won't call as radiuses, we will call as radii. Second example, all rectangles and squares. Why we can't include all triangles are similar triangles? Why only rectangles and squares and circles are including? Anyone?
So because they can also be congruent. Sir.
No, I can say all congruent is similar.
Yes, sir.
Congruent is similar, but all similar can't be congruent. There is just fine difference. When I am talking about triangles, parallelograms, and rhombus, a little bit more we have to discuss about similarity. I can't say all the triangles are similar, but I can say all the rectangles are similar. What makes all triangles are not similar? What is exactly the meaning of similarity? Anyone? The meaning of same size, this is not meaning of same shape. It's meaning of not same kind of figure. Triangles are same kind of figure, but it is need not to be same shape. When you can say it is same shape, why all rectangles are same shape? Rectangle is a particular defined with respect to all the sides. You can say rectangle, all the angles are also exactly how much?
90 degrees.
Rectangle, or if I am taking square, even you take anything, any rectangle or any square, the angles are all same, only the length and width is changing. The angles are always same, 90 degrees, 90 degrees, 90 degrees. That's the reason we can say any rectangles are similar. But when it is coming to triangle, if I'm taking a triangle of, and if I'm taking a right angle triangle, both belongs to triangles category, but both are not similar. What is the difference here? Similarity means same shape, but it is not same in shape. It is different kind of triangles. When I can say similar triangles, based on this discussion, guys, when I can say the similar triangles, there is a little bit more we have to discuss about the similarity concept.
Sir, when they have the same size, same shape, but not the same size.
Yeah. It is need not to be same size. It should be same angles. So to explain the similarity condition, why we particularly we are discussing about the similarity triangles, because all rectangles are similar, but all triangles are not similar. So when I'm talking about similarity condition for any polygons, based on the previous discussion, it should follow two conditions. One is their corresponding angles are equal. I'm talking about any polygon. Any polygon should be similar polygons. Their corresponding angles are equal, and their corresponding sides are in the same ratio. Corresponding sides are in same ratio. Understand, guys, what is the meaning of similarity? So what is the meaning of similarity means? I will explain with a small example. Yeah, I'm taking this diagram. This is one monument, one of the famous monument in Hyderabad. So this name is Charminar. I'm taking this diagram. I'm copying in my notebook. What is the difference between all these three figures, guys?
Sir, the
What is the
size
difference?
is different.
But
Size is different, sir.
size is different. Only size is different. Rest of all the things are similar. Even the size is also different in a proportion, correct?
Yes, sir.
Yes, sir.
So if I'm comparing with the original, I am decreasing the size with a proper ratio. Suppose if I'm taking the actual height of the Charminar is, for example, 100 meters. For example, sorry, 10 meters. If this diagram is only 1 centimeter, I am decreasing its height 1000 times than original. I am increasing the size 10 times of the original. I am decreasing the size 20 times of the original. Or this is, if I am increasing all the dimensions by 100 times, I will get this diagram. In this case, all the sides you are increasing in particular ratio, particular number of times. Those kind of changing figures is called similar figures. You can't say if I'm having a triangle of 20 centimeter, 10 centimeter, and 15 centimeter, I can take 20, 10, and this is 5. Both are similar, even though angles are same. Understand, guys, what I'm saying? Even though angles are same, I can't say. It is not easy to say, because if I am changing the sides, it should be in common ratio. Suppose if I am saying this is 5, this is 10, this is 7.5. Now I can say this triangle is decreased exactly, each and every side is decreased exactly half of the time with same angles. So I am zooming in, zooming out. Simply, the best example is zooming in, zooming out. What are the different zooming levels? What are the images you are getting? This is one kind of zooming. This is another kind of zooming. This is another kind of zooming. All represent same figure. And zooming means what? Particular ratio you are increasing and decreasing the size. Those figures are called similar figures. That's the reason the condition for the two similar figures is their corresponding side should be in the same ratio. Their corresponding angles should be equal. Corresponding angles should be equal. Corresponding ratios should be same. So the meaning of same ratio. What is the meaning of same ratio? Same ratio of the lengths of corresponding sides is known as scale factor. How many are very much interested with automobiles, guys? Cars or planes? Anyone having any collections? Toys? Guys, are you clear with my question? Representative factor of the representative fraction, not factor, fraction. Representative fraction of the polygons. If you just go to any automobile companies or any designs, any engineers, before they are designing any houses, civil engineers or any buildings, they will construct a prototype. What is the prototype, guys? What is the prototype? Suppose if you are going to design a bench car, before designing the bench car, only structure point of view, they will design a small car of like handy size car, like a toy with the same. They will say 1:500. What is the meaning of 1:500? They are decreasing the size of the car in all dimensions 500 times. The car size is 500 centimeter diameter. The toy is 1 centimeter diameter. So then in case it is similar. Maybe you are taking some other car, might it is not similar. Similar means the same figure, they are reducing exactly in the same ratio or they are increasing exactly in the same proportion. Those kind of figure, similar, different figures are called similar figures. When it comes to congruent, exactly it should match. If it should overlap, then only we can call as congruent. So can you give any examples of similar triangles? Guys, can you give any examples of similar triangles? Any examples of similar triangles? Examples of similar triangles. Guys, please.
Sir, what is the meaning of prototype?
Prototype means, that's the reason anyone are interested in automobiles or airplanes or anything. You brought any airplanes in any shop malls or anywhere? Anyone? Still are you interested? Any buildings? Prototype means, suppose if you are having Airbus A380, it is having a prototype. The prototype means almost you can carry in your hand. Before designing the main aircraft, they will design a aircraft with this ratio, that is 1:1000. 1:1000 means they are decreasing the original aircraft 1000 times, and they will make a aircraft exactly 1000 times smaller than the original aircraft. That model is called prototype. Even same house also, if you go to buy a house in real estate offices, they will keep a prototype house. Prototype house means they will construct a small house on a table, which looks like your original house. They will make a scale. Suppose your house height was 12 feet. They will make only 1 feet. That means each and every side they will decrease by 12 times. Understand, guys, what is the meaning of prototypes?
Yes, sir.
Yes, sir.
Sir, like a
Yes,
sample
sir.
Find out
model.
the toys. Find out the prototype toys in Amazon everywhere. Let's see, I can show anything through the net.
So Sir, it is just a sample model before making the
The
product.
sample model is little different. Sample model is it's original only. Sample means they will give one model. They mean they will release one piece in market to test. That is sample. Prototype is different. There is a slight difference between prototype and samples. 1 second, I will try to check. You can see generally in toy shops, little bit costly toy shops. I can't say it's a cheap. They will mention the prototype. They will say it is exactly same as your original car. That means how the original car looks, the same it will looks, and they will give the ratio also. Suppose if I am looking this, if you, I think I shall share. If you see here, this is 1:32 ratio. What is the meaning of 1:32 ratio? Means they decreased the toy size 32 times the original. They decrease the toy size. That means this size. If I am increasing this toy exactly 32 times, it look like your original car. Lengthwise, height wise, dimensions wise, wheels wise, everything. Understand, guys, what I'm saying?
Yes, sir.
Yes, sir.
Prototype models. These are called prototype models. Usually, civil engineers they will do prototype. Architects, these people will do prototypes before they are going to construct the original thing. If there is any flaws, there is any kind of mistakes, they can identify in prototype. You will get in toy shop mostly will get aircrafts, your ships, in cars and all. They will mention on the box the ratio 1:20, 1:30, 1:500. This 500 means when compared to original 500 times they reduced the size. Exactly 500 times they reduced the size. In original, if it is 500 meters, in real it is only 1 meter. Like your prototype size is only 1 meter, but when it comes to real, 500 meters. So that is called prototype. These kind of things are called similar. Now, my question is, can you give any example for similar triangles?
So equilateral triangles with different sides.
All equilateral triangles. All equilateral triangles are similar. All equilateral triangles are similar. If I am increasing the equilateral triangle means all sides you should increase in the same ratio. 2, 2, 2 or 5, 5, 5. Or if I am taking 6, 6, 6. 1, 1, 1. I am increasing 2 times, I am increasing 5 times, I am increasing the 6 times. These are all not congruent, but I can say all these are similar because all represents equilateral triangles. 60, 60, 60. That means if I am drawing a triangle, if I am zooming out and zooming in, you can get the different sizes. See here. You can get. If I am zooming out, you can get different sizes. Got it, guys? What I'm trying to say?
Yes, sir.
Now, what are the conditions? Can you able to recollect what are the conditions I said to say two polygons are similar? Condition.
So corresponding angles should be equal, sir. And the corresponding sides are in the same ratio.
Polygons are similar. First one is corresponding angles are same or equal. Second one is corresponding sides are corresponding sides are
In same ratio.
the same ratio. Then in case of congruent, what is the condition? In case of congruent, what is the condition? In case of congruent, what is the condition for congruency? So I'm asking, what is the condition for congruency? Sanyu, Rita, please. Small difference between these two. Same statement will come, but little difference. Corresponding angles are same as it is. First condition is common
Yes,
for
sir.
both.
And corresponding sides are also same.
Yes, instead of same ratio, it should be same. The corresponding angles are same, the corresponding sides are same, then only I can say it is congruent. Congruent means in general rough language, if I am keeping both the figures one on each other, if I am overlapping on each other, the boundaries of the figures should match exactly. Then only I can say congruent. Am I right or wrong, guys?
Yes, sir.
Yeah. One more example of similar triangles. Any other examples of similar triangles? Any other example of similar triangles? Please, guys. Any other example of similar triangles? Any other example of similar triangles?
Sir, isosceles and scalar are not similar, right?
Correct. Isosceles and scalar are not similar. We can't say. That is depends upon the given data only you can say. But without giving in data, any set of triangles are similar. Right angle isosceles. Do you agree? All the right angle isosceles are similar or not? Guys,
Yes.
right angle isosceles.
Yes, sir.
Yes, sir.
Yeah. Now, how I can explain similarity condition? With mathematically. Now we know the definitions and all the things. If I'm giving the two diagrams, how I can explain the similarity conditions mathematically, that we will see now. Suppose if I'm having two figures like this. And might be it looks a little bit strange. Yeah, I won't make it strange. This is 100 degrees, 110 degrees, 62, 88, 60, 90, 90 plus 60, 150, 210, 360. And this is 62, this is 88, and this is 110, and this is 100. Now it is easy to explain. First A, B, C, D, P, Q, R, S. How I can write my condition mathematically here? If I want to say A, B, C, D and P, Q, R, S quadrilaterals are similar, find angle A is equal to what angle? Angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R, angle D is equal to angle S. Now, first condition is over. Corresponding angles are same. Corresponding angles, corresponding sides should be in the same ratio. So, I am starting with angle A. Angle A and angle B. What is the side AB? So, angle A and angle B contains angle P and angle Q. So, AB by PQ. BC angles QR. BC by QR is equal to CD by RS. And if I'm taking AD, what are the angles associated with AD? PS. This is how corresponding sides. Suppose if I'm altering, if I'm rotating this diagram also, you should not confuse. If I'm rotating this diagram also, based on the angles, you have to take the corresponding sides. A and B associated with P and Q. B and C associated with Q and R. C and D is associated with R and S. The corresponding side of C and D angles are CD. The corresponding side of RS angle is RS. So this is the corresponding sides are in the same ratio. So these are the two conditions mathematically we can explain about the similarity condition. Is it clear, guys, what I'm saying?
Yes, sir.
Yeah. Next one, guys. Yeah, I think we can start the exercise with this data. We'll start the first exercise based on the similarity conditions. We started with similarity, projections and all we done. Yes. Can you complete the first exercise, guys? It's just the basic questions. We'll explain theoretically. Fill in the blanks using based on the similarity conditions. What is the first one answer, Harita?
Sir, all circles are similar.
Yes. Second one answer.
Sir, all squares are similar.
Third one. Anyone? Sunny,
Sir, all equilateral triangles are similar.
all equilateral triangles are
Similar.
all equilateral. Yeah. Fourth question.
So corresponding angles are equal, sir,
Hmm.
and their corresponding sides are proportional.
Corresponding angles are corresponding. Two polygons of the same number of sides are similar, and their corresponding angles are same. Their corresponding sides are in the same ratio for similar condition. So second question example, Sanyu, can you try the second question example? Guys, what is the examples of similar figures? Similar figures. Anyone can give the examples of similar figures?
Two squares and two rectangles.
Two squares, any two squares, two rectangles, two circles of different radii. Non-similar figures. Isosceles triangle and equilateral
Isosceles
triangles.
triangles and
Equilateral
scalar triangles.
Scalar triangles, anything. Isosceles and equilateral also I can say now.
Sir, but equilateral triangles are similar, right?
No, I'm saying one isosceles triangle, one equilateral triangle. Both are
Yes, sir.
non-similar. Both are non-similar. That's what I'm trying to say. Okay.
Yes.
What about the third question? Whether it is similar or not?
No, sir.
Why?
Sir, because the shape and size both are different, sir.
Shape and size both are different. Because one is showing parallelogram, another one is showing
Square.
maybe the ratios is, see, might be here the sides are in the same ratio. If I'm multiplying each and every side with 2, I'm getting same as all the sides of this diagram, but this is 90, this is 90, this is 90. All the angles are not same. First condition is not satisfying to say here. From here, what conclusion I can give? Even corresponding sides are in same ratio. Sorry guys, please. Corresponding sides are in same ratio. It's need not to be similar, correct? Compulsory, the first condition should satisfy. Only because of the second condition is correct. I can't say all the corresponding angles are same. If corresponding angles are same, whether it can be similar or not, we can able to prove that we can see in upcoming. Is it clear, guys? How to what kind of points we can discuss from the question number 3? Guys?
Yes, sir.
Yeah. So we'll move to the next question. Similar triangles. We got the similar triangles. Based on this, we can do an activity. It's very simple. Projection of a triangle. You can take a common angle, from that you can create a similar angles. Suppose if I'm taking, how many triangles you can see, guys? O, A, B, P, Q, R, S, and 1, 2. How many triangles you can see, guys, here?
5, sir.
5 triangles.
5, sir.
Is it possible I can say all the 5 triangles are similar?
Yes, sir.
Yes, because the lengths are increasing in a common proportion. And how I can say the angles are same? Corresponding angles are same. How I can say? How I can say the corresponding angles are same? How I can say the corresponding angles are same? See here, if I'm taking this is 90, this is 90, this is 90. If I'm taking this is theta, this theta is common to all triangles. Automatically, this is 90 minus theta. 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 The first condition is satisfying. How I can say the second condition is also same? Because just you are increasing the sides of the triangle with a common angle. If you are increasing the sides of the triangle with a common angle, then we can get similar triangles, same ratio. This, how I can prove mathematically? We are having a proof. How I can prove this one? We are having a theorem.
Sir, can you repeat once more?
Suppose if I am having a triangle, if I am increasing the sides into common with common angle, this theta I am keeping like this. I am increasing the remaining all the sides like this. I am not changing this angle, but I am increasing. If I am dragging this, if I am zooming out this one like this. What I'm saying, man?
Yes, sir.
What I done? I'm just projecting a point. I'm projecting in one particular angle. See here, here your angle is fixed. I'm projecting like this. Even though if I'm taking like this, if I'm increasing this one, and you just join any lines here, what is happening? Because of these parallel lines, if I'm saying this is a parallel line, then only I can say all these angles are same. Based on your, what is the condition that is? This angle is equal to this angle. What is this angle? Alternate angles. This and this. 1 and 2 is alternate angles or what angles? Transversal
Corresponding
angles.
angles, sir.
Corresponding angles. The corresponding angles are same. There are 4 corresponding angles here on top. The 4 corresponding angles at the bottom. Your angles are same. But whether the sides are also same in proportion or not, we are going to prove. We will have a theorem. In previous case, even though sides are in the same proportion, it is need not to be in same similar, but if all the angles are same, definitely we can prove it is as the similar triangle without knowing whether the sides are in same proportion or not. So before going to this, we have to go with some common theorems. The first one is a basic proportionality theorem. So how to explain the basic proportionality theorem is, this is the thing. Whatever thing I explained in general in class, we will do as an activity. So what we will do is, we will just that activity I will explain. If you want, you can try. I'm taking a triangle, a random. You can draw one triangle, random triangle you can draw. So you can draw a random triangle on A4 sheet and take a scale, draw the parallel lines like this. Draw the parallel lines like this. So for understanding, take 2-3 lines, then you will get the less number of triangles. So this is A, B1, C1, B2, C2, B3, C3, B4, C4, and B5, C5. For all the triangles, A is the common angle. Suppose if I am taking A, B1, C1 triangle, with the protractor and with the scale, you can measure all the 3 angles. Guys, understand what I'm saying?
Yes, sir.
So based on, I'm saying complete practical we are doing. Anyway, based on the parallel lines concept, these 2 angles also same, these 2 angles also same, these 2 angles also same. That means C1 is equal to C2, C2 is equal to C3, C3 is equal to C4. Why? Alternate angles now, guys. Correct. Take the lengths, measure the scale, find the AB dash length, B dash C dash length, and AC dash length. And again, this is B1, C1, C1, B1, A, B2, B2, C2, and A, C2. Take the ratios. You will get the same ratios. You will get the same ratios. And if I am taking the ratio of A, B1 by B1, B2 is equal to AC1 by C1, C2. This ratio is also you are getting the same. So if I'm getting the same ratios, what it is meaning is this line is dividing. If the line is parallel to the base of the triangle, that line is dividing the triangle into another triangle. The sides are dividing exactly into the same ratio. Suppose if I'm drawing a line parallel to a base, BC is the base of a triangle and PQ is a line drawn the parallel to base BC, then PQ is dividing AB and AC in the same ratio. This theorem is called basic proportionality theorem. So like this practically you can explain. Using an activity you can explain practically about the basic proportionality theorem. Because basic proportionality theorem means it is valid for any triangle. If I'm drawing a line parallel to the base of the triangle, you can choose any base. You can choose any base because 3 bases you can consider. Each and every side we can consider as the base. So if I am dividing a triangle like this, a line drawing parallel to the base of a triangle, that means that line is intersecting remaining 2 sides of the triangle. That intersection is dividing the 2 sides in the same ratio. So this is called basic proportionality theorem or called Thales theorem. So the mathematical proof we can do 2 ways. One is practical way you can able to prove, and second is logically. That means mathematically we have to prove. Those things we are calling as theorems. With the help of your 7, 8, 9 plane geometry concept, we are going to prove all these theorems in this class. I mean in this grade 10. So in next class we are going to start with all the theorems. With the help of the theorems only, we are going to solve the numericals. First 2-3 sessions completely we are going to discuss the theorems. The gentle reminder, keep it in mind, the theorems are like numericals. Don't feel each and every theorem is like a theory and don't mug up. There is some logic. I already told you all these theorems are deriving from your previous concepts. Identify the logic, how we are doing the numericals in AP, how you are doing the numericals in quadratic equations, different little bit higher level numericals. The same way you connect this theorem to your previous concepts like grade 9 and grade 8 concepts, then automatically each and every theorem you can feel as a normal question. No need to feel that is a particular a theoretical concept. Is it clear, guys, what I'm saying? So the theorem will take a little bit more time. So I'm winding up the session. In tomorrow class, we are going to start with the theorems.
Sir, what did you say now, sir? I had got disconnected.
No, what I'm saying is theorems generally what we will do is we will write neatly on a paper. We will try to keep like a formula. Many people I found that they will mug up. Openly I'm saying. What I'm trying to say is theorems is deriving. There is a logic. It's like a numericals. Don't keep it in mind. The theorems are like some theory kind of things. It's like a proof of something, a proof of a statement. If you are able to connect it properly to your basic concepts of 9th and 8th plane geometry, the theorems is also like a numerical. It's also like a numerical. How you are going to solve your previous classes like quadratic equation, higher level numericals. Same as you can remember as a numerical. That's what I'm trying to say. So don't keep it. Theorems are different and numericals are different. Might be I can say the theorems are little bit higher level numericals. Is it clear, sir, what I'm saying?
Yes, sir.
Yeah. So we will start with the basic proportionality theorem. We will meet in next class. Might be this week we will have some extra session. Because last month I missed one class. I am unable to compensate. So this week we may have one extra session. Might be it is on Friday or Saturday. I will let you know through the institute. Yeah. Anyone having any doubts, please let me know. Otherwise, I will wind up the session. Please let me know, guys. Anyone having any doubts?
No doubt, sir.
Yeah,
No
we'll
doubt,
meet,
sir.
in next class. Bye, everyone.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.